Okay, so this paper contains mostly grade C questions with some grade B questions as well, based on shape and measure, and it's a paper where the questions have been taken off calculator allowed papers. So, first few are to do with transformations. This question is telling you to rotate this triangle 90 degrees anti-clockwise about the point 2 minus 1. So when you're doing a rotation, unless it's 180 degrees, they need to give you extra information. They need to tell you which direction the turn is going to be and where to pivot the rotation about. If it's pivoting about different positions, then it will end up in a different place. So with a rotation question, you're allowed to use graph paper, and you'll be given graph paper in the exam. And what you do is cover the grid and copy onto the grid the shape that needs to be rotated. And then if you put a little arrow pointing up, what you want to work out is which direction that arrow is pointing following a 90-degree anti-clockwise turn. Anti-clockwise is in that direction, so after a quarter of a turn I'm going to keep this turning this tracing paper until that arrow is pointing in that direction. And in order to perform the rotation, I'm going to pin the tracing paper down on the point 2 minus 1. So 2 minus 1 is there. Let's just check. 1, 2, 3, 4, 5. Yeah. So I'm going to hold the pen there and turn that tracing paper till that arrow is pointing entirely in that horizontal direction. And when that's done, you can see the outline of where that rotation is going to end up. So it's going to end up starting at -1, and going down like that, across, and there you go. So that is worth 2 marks. If you'd have rotated it in the wrong direction but about the right point, then you would have got 1 mark for that. So 1 mark for performing a 90-degree rotation, 2 marks if you get it about the right point as well. Question 2 is a reflection, and with a reflection you need to be told an extra piece of information, which is where to place the mirror. Where are you going to put the reflection line? And they're telling you here that the reflection, the mirror, is going to be placed at x equals 2. Now x equals 2, this is your x-axis, and this is the point where the x coordinate is 2. Now anywhere on that vertical line will have an x-axis as 2. There would be 2, 2, that would be 2, 4, 2, 6, 2, -2, and so on. So the mirror is a vertical line which is going through that x equals 2 point. So the most common mistake that people make is that because the x-axis is horizontal, they would draw x equals 2 up there, but up there would be the line y equals 2 because the y coordinate is 2. So that would be a pretty common mistake. When you're then using a reflection or performing a reflection, once you've got your mirror line in place, the reflection is always an identical perpendicular distance or right angle distance from the mirror. So if we start here that point there is 2 squares from the mirror, so in the reflection that will be 2 squares from the mirror. That one is 4, so it will be 2, 4 that side, and then you can see then the shape being formed. That point there is 1 from the mirror, so it'll end up 1 that side, like that. This point is 3 from the mirror, so in the reflection it will be 3 from the mirror. And what I would strongly suggest you do with transformations is use a pencil when you're drawing them. I'm using a pen so it stands out on the video clip, but use a pencil so that if you think, hang on, no, I've made a mistake, you can rub it out easily. And you can see there that the reflection should form a symmetrical pattern then about the mirror line, and I can see there that that is going to be symmetrical. So there's 2 marks if that's what you've done. There'd be 1 mark if you performed a reflection, a correct reflection, but having the mirror somewhere else. The next one transformation that we need to be comfortable with is a translation. Now what a translation does is it moves the shape that far, that many squares in the X direction, that many squares in the Y direction. It doesn't change the size of the shape all the way around, it just moves it. So this is saying we're going to take that point there and we're going to move it -3 in the X direction, let's try and get the exposure right. So that means 3 in this direction, 1, 2, 3, and then -8 means we're going down 8. 1, 2, 3, 4, 5, 6, 7, 8. So we've gone 3 in that direction, and then 8 in that direction. And once we've located that top point, everything else stays the same. So that is our translation. And then for part B, write down the vector that will reverse this translation. So what that means is, well, if you started there and you wanted to get back, you'd be moving +3 and +8. So all you're looking for there is +3, +8. You don't even have to put the pluses in. 3, 8 would be good enough for that. So that's a translation. Enlargement. So this enlargement is telling you to use point B as the center. If you're not given a center, then you can draw the enlargement any way you like. But if they give you a center, you have to enlarge from that point. So we're enlarging by a scale factor of 2. So my enlargement is going to be twice the size of that. So that's side there is 2. It's going to be 4 in the enlargement. But it's not enough just to draw that 4 anywhere. So this is what you do. Take each point of your original shape and work out how far across and up and down you need to move to get from the center of enlargement to that corner. So with this one you can see I'm going down 1. So in the enlargement I'm doubling that. So instead of going down 1, I'm going down 1, 2. To get from B to this corner I'm going down 1, left 2. So in the enlargement I'm going down 2, left 4. So there's my enlargement, but its position is right as well. Once you get the position, you can then pretty much continue the enlargement. So I know now that, drawing that in there, this side is 3, so in the enlargement it's going to be 6, 3, 6. And then I've got this last point to locate. So from here to there I'm going right 2, up 3, So in the enlargement, I'm going right 4, up 6. 1, 2, 3, 4, 5, 6. If I then join those points together, that gives me my full marks. So there's 1 mark if you draw the correct enlargement anywhere. For both marks, it has to be relative to the point that they've asked you to draw it from. In this one, it's inside the shape. It's not always. It could be outside the shape, wherever they decide to put it. Okay. The other thing that they can ask you to do is to describe a transformation that's already happened. So that's exactly what this question does, and there's a big clue in the number of marks, because you'll get a mark for each piece of information to describe it. So hopefully you can see that that has been turned, and turn, the mathematical word, is rotated. Hopefully you can see it's gone through a quarter of a turn, which is 90 degrees, and it's gone in that direction. So we've got anti-clockwise. So you get a mark for rotated, you get a mark for 90 degrees anti-clockwise, because if you remember from the first question, in order to perform a rotation, you need to be able to pin your tracing paper somewhere. And this is unlikely on an intermediate paper to be particularly difficult, so I would suggest the place to start is by pinning at the origin. Okay, so that's what I'm going to do. Left-handed view, which isn't helpful. So if I pin there and turn it to 90 degrees, it fits perfectly. So the last bit for the last mark is about, again the mathematical word is origin, but if you put 0, 0, means exactly the same thing. So either about origin or 0, 0 would get you the third mark. So those are transformations. Question 6. I forgot what it is. Timetable. Time questions. Now remember, on a paper 2, you're allowed to use a calculator, and on your calculator you have this button here, which looks like a series of full stops and commas, which is your time button, and it's really useful when working with time. Not for everything, but often. So let's get the context of this. The following table is an extract from a coach timetable for coaches going from Swansea to Gatwick North and Gatwick South airport terminals. How many coaches arrive at Newport between 4 AM and 10 AM? So Newport is here, which means that this row are the times that all the coaches are in Newport station. So there's a coach there at 3:45, 5:45, 7:55, 9 o'clock and 10:15. How many of them are between 4 AM and 10 AM? Well, that's before 4 AM. That one fits in. That one fits in. That one fits in. That's past 10 AM, is 10:15. So there are 3. Part B. Mary catches the 04:45 coach from Bridgend. So 04:45 from Bridgend. So let's find that. Bridgend 04:45. To go to Gatwick South. So Gatwick North, Gatwick South. How long should she be on the coach? So let's just write down what we know. She's going from 04:45 to 09:55. So to work that out on our calculator, we want to work out the difference in the time. So if we do 9 hours 55 minutes, take away 4 hours 45 minutes, we can see that it's 5 hours 10 minutes no seconds. So she's on the coach for 5 hours and 10 minutes. So there's 2 marks for that, one for recognizing the right times and then one for working out the time scale between them. Mr. and Mrs. Williams are booked on the 15:20 flight from Gatwick North. They catch the 7:25 coach from Cardiff. Now, don't get mistaken here by trying to find that on the timetable. This is the coach timetable. It's got nothing to do with the flights. So the 7:25 coach from Cardiff is this one, and they're going from Gatwick North, which is this one. How long will they have at the airport before their flight takes off? So they arrive at the airport at 11:55. They take off at 15:20. So again, on our calculator now, if we do 15:20, so 15:20, you have to press the button after the 20 as well. Take away 11:55. You can see there 3 hours and 25. So it's really straightforward to answer those questions if you can use a calculator. Okay, part C. One of the coaches diverts to another town between Newport and Heathrow. Which coach is it, and explain how you know? So Newport to Heathrow should, on a timetable, take more or less the same amount of time on the timetable. It may vary by a few minutes depending on the time of day for the traffic, but it shouldn't be hugely different. So with this one, if we do 6:35, take away 3:45, that's 2 hours 50. This one, 8:55, take away 5:45. 8:55, take away 5:45. 3 hours 10. 11:05, take away 7:55. 3 hours 10. That one I can do in my head, 4 hours. That's a big difference. And then this one, 12:55, take away 10:15, 2 hours 40. So that one has got a gap of 4 hours. So which coach is it? So it's the 9 o'clock from Newport, or you could say the 7 o'clock from Swansea. It doesn't matter so long as you're clear to identify the coach that's in that column, because it takes much longer, 4 hours, than the others. So we've been looking at what the differences are. That's the one with the largest difference. So that's why that is. Divide 18 hours 45 minutes by 5. Give your answer in hours and minutes. So this is a really easy question if you know about that time button. So you're going to do 18 hours 45 minutes divided by 5 equals 3 hours 45. It's as simple as that. The journey from Edinburgh to Dundee takes 2 hours 20 minutes by car. If the towns are 100 kilometers apart, calculate the average speed of this journey. Give your answer to the nearest kilometer per hour. So that instruction there is going to earn you a mark. So it's important that you remember that that is there. Right, you need to know, and this is how you tend to remember it from science, the relationship between speed, distance and time. Speed is distance over time. Time is distance over speed. Distance is speed times time. So the speed is going to be distance over time, and again use your time button on your calculator. So we're going to do 100 divided by 2 hours 22 minutes. And this time, because the answer we need, we don't want a time, we want a speed. Now we need to turn that from time form to decimal form. So just like with fractions and decimals, your SD button here, that's it as a fraction, that's it as a decimal. So it's going to be 42. Oh, I just realised I put the wrong time in there. I've got 2 hours 20, 2 hours 22. So let me just put that right. Start again. 100 divided by 2 hours 20 minutes. S to D 42.8 blah 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 blah. Give your answer to the nearest kilometer per hour, so they want that to the nearest whole number. 42.8, 0.8 takes it to the next one up, which is 43 kilometers per hour. So there's 1 mark there for doing distance over time. The common mistake to make would be to do 100 over 2.2. You won't get anything for that. So it's 2 hours 20 minutes. That would get you the second mark, but because there's an instruction there to round it to the nearest whole kilometer per hour, you would need to do that in order to earn that credit. Okay, next we've got some bearings questions. So an oil ship is sailing in the North Sea. It is 150 kilometers from Sunderland on a bearing of 065. So you need to remember that when you're measuring bearings, you're measuring from north. North is 0 degrees, and you're turning in a clockwise direction. And the from tells you where to put the measurer. So from Sunderland means I'm measuring from there, and the 0 lines up with north. So the center of my measurer goes over the dot for Sunderland, and the 0 line is there lining up with north. And it's 65 degrees. It's a 3-figure bearing, so if the number is less than 100 degrees, you add a 0. So I need to go 65 degrees. It's the outside scale, 0, 10, 20, 30 and so on. 60 is there, 70 is there, 65 is somewhere in between. So that means I know that my ship, or the ship, is somewhere on that line, but I don't know where. Now in order to work out where, it's telling me it's 150 kilometers and the scale is 25 kilometers is 1 centimeter. So 4 centimeters will be 100, and I want another 50, so that's 2 centimeters would be 50, 6 centimeters will be 150. So there's different ways of doing that. You could just divide it in however you wish to do it. But that means that I've got to measure 6 centimeters along this line to work out where the boat is. So there is 6 centimeters. So that angle there is 65 degrees, and that distance is 6 centimeters, which represents the 150 kilometers. So that's where my ship is. Plot its position on a diagram, done. And give its bearing from Aberdeen. So now I've got to work out how to find it from Aberdeen. And for that, draw yourself on the line that joins those two. I'll do it with a dotted line just so it appears differently. And I need to work out what that angle is. So get your measurer again, the centre now on Aberdeen, 0 lines up with north, and how far along am I going? 130 is there, 131, 132, and there'll be a margin of error allowed on that. So if you've got 130 or 134, then that will be fine. It also, if you measured that wrongly, they would then have to measure the bearing for your incorrect answer. So there's quite a few ways to earn those marks. On the map below, 1 centimeter represents 5 kilometers. The ship is on a bearing of 027 from Fishguard. Fishguard. 027, 20, 30, 27. He's on this line somewhere. Don't know where. So that's your 27 degrees. And 330 from Aberaeron. Aberaeron is there. 0 is there, and 330 around the outside takes us back to there. So the ship is there where the two lines cross. How far is the ship from Aberystwyth? Well, Aberystwyth is there. So what I need now is to measure this distance, which you can see is 6 centimeters, and 1 centimeter represents 5 kilometers. So 6 centimeters times 5, every centimeter is 5 kilometers, will be 30 kilometers. So for that one, you've got 1 mark for the 27, 1 mark for the 330, 1 mark for measuring the 6 centimeters, and the final mark for turning it into kilometers. Okay, now we're on to some area and volume questions. Calculate the area of the trapezium. There's another instruction here, give the units of your answer. So one of those marks would be for correctly writing down the units of the area. I've published this here. It wouldn't appear there on the actual exam paper. It would be on the front page, but you need to remember it's there. Area of trapezium equals half A plus BH. So the area equals half. Then A plus B, you can see on the diagram, are the parallel sides. So that would be 5.6 plus 9.8. I'm going to ignore that. And then the H is the perpendicular distance between parallel lines. So what they've done here to confuse you is to stick two different distances in, but hopefully you can see the perpendicular one there, the one with the right angle, is the 2.8. So all I've done there is written in exactly the same way as you can see there. The formula, but I've substituted in the numbers of the shape. Now we can put that into the calculator. All we have to remember is that when you're working with brackets, if you don't see anything, what we have there in arithmetic are the times. So we can type that in now exactly as we see it. So we've got a half times, open bracket, 5.6 plus 9.8, close bracket, times 2.8. So it's written exactly as we see it, and turn it into a decimal, and we get 21.56. That answer only worth 2 marks. In order to get the third mark, you need the units for your answer. We're in centimeters, but we're area, so we have to have square centimeters. So that's a trapezium. They're not always going to be drawn that way. They could confuse you by having the parallel sides being vertical. Doesn't matter, so long as you recognize that the A plus B is for those two measurements, and then the H is the distance between them. Question 12. A company's logo is displayed on the outside of its factory wall. The shape of the logo is made using a rectangle, a right angle triangle, and a semicircle as shown below. Some of the lengths are shown on the diagram. Calculate the total area of this logo. Extra instruction. Give your answer to 1 decimal place. So one of those marks is for a 1 decimal place number. Right, well, let's look what we've got here. We've got a rectangle, which hopefully is the easiest thing for you to work out. Length times width, 5 times 4, 20. Then we come to the triangle, which is half, and then it's the sides that are right angles to each other, because it's what you've got there is half a rectangle. So it's a half of 10 times 5. 10 times 5 is 50, half it, 25. Then we have the semicircle. This is the hardest bit. Area of a circle is pi r squared. Now the radius of this r bit isn't 4. The radius is the distance from the center out. So the radius is 2. But we don't want a circle, we want a semicircle. So it's going to be half the area of the full circle. And we can plonk that into our calculator exactly as we see it. So we'll do a half times pi. Pi on your calculator is shift and then it's the standard form button. You can see the pi just above it. So shift pi times 2 squared. So it's on my calculator in exactly the same way I see it there. Press equals 2 pi, turn it into a decimal, 6 point, for one decimal place, 6.3. So I know that this bit is 20. I know that this bit is 25. And I know that this bit is 6.3. So the total area, I'm now going to add those together. 20 plus 25 plus 6.3, which is 45, 51.3. Now this time, I'm going to put the units in, and it's not centimeters, it's meters. But whether you chose to do it or not, or got the wrong units like I just did, there are no marks for the units anyway, so 51.3 would have been fine. The additional mark there is for having it to one decimal place, which we did there. We could have left it till the end, but as long as your final answer is one decimal place. So the marks for that, there's one mark for getting both of those. Then there's a mark for recognizing that the radius is 2 and finding the area of the semicircle. We'll get the other mark, and then the final mark is for adding them up. Sorry, and then adding them up, and the final mark for one decimal place. One other formula that you're given on the front of your exam paper, I'll just show you here, is this one. Volume of a prism is the area of cross-section times length. The volume of a prism is a shape that has got what we call a uniform cross-section. It means we can cut this up, and however many times we choose to cut it, this area will always be the same. So if you imagine cutting up a sort of Swiss roll cake, as long as you cut it downwards, each slice, the face will be the same. So once we know that, if we can calculate the area of the cross section, multiply it by its length, and we can find its volume. In these next two questions, we have prisms. This is a triangular prism, which means if we can work out the area of its face and then multiply it by 14, it'll give us its volume. Again, what they've done here to be nasty is they've given you two possible values for height. What you have to remember is it's always the perpendicular height. You want to make a rectangle out of it, but you can't make a rectangle out of that because that's at an angle. So the area of the face is a half times 5 times 8, which is 40. Half of 40, 20. So this bit is 20. So the area is the the volume is the cross-sectional area times the length. Which is 280. This is another trigger. You'll only get one of these in an actual exam where they're telling you to give you units. So there's one mark for that. Units of volume, well, it's centimeters, but for volume it's cubic centimeters. Calculate the volume of a cylinder. So this is a prism with a circular face. The radius is 4.5, the height is 10.3. So the volume will be pi r squared to give the area of the circular face times 10.3, and again here state the units of your answer. So we can type it in exactly as I've written it. Pi times 4.5 squared times 10.3, 655, and let's give it to one decimal place. 1 over is 5. If it's 5 or bigger, it rounds up. So if you'd have given 655 there, or 655.3, that's fine. They want the units, volume, centimeters cubed. Moving on to angle properties. ABCD is a square. ABCD, that's a square. What do I know about the angles in a square? They're all right angles. How many degrees in a right angle? 90. So I know each of those are 90. So draw them on the diagram. Triangle DEF is equilateral. Equilateral triangle. What do I know about equilateral triangle? All the sides are the same length. DEF, DEF. All the sides are the same length. And all the angles are the same size. And if the angles are the same size, they're all 60. Triangle AFD is isosceles, with AF equal to AD. What do I know about isosceles triangles? Two equal sides with the angles at the end of the equal sides the same. EDC is a straight line. What do I know about straight lines? They all add up to 180. Showing all your steps, calculate the size of angle AFE. So that one there is what I'm trying to work out. Right. So I know that ABCD is a square. So all angles 90 degrees. DEF is equilateral triangle. So all angles 60 degrees. EDC is straight line. So that has to add up to 180. So that means that I know that 60 and 90 and that must add up to 180. So this is 180 less 150, which is 30 degrees. So if I know that is 30, I know that is 30 as well. And AFE is all of that. So AFD is isosceles. So angle ADF, which is that one, is equal to angle AFD, which is equal to 30. So AFE is 30 plus 60, which is 90 degrees. So how is that one marked? One mark for the 90s, one mark for the 60s, one mark for working out the 30, one mark for the isosceles making that one 30, and one mark for your final answer. Question 16. Parallel lines. Find the size of the angles marked A, B, C, D, E. Now, if it helps you, often when we teach parallel lines, we tend to have the parallel lines being horizontal. But they don't have to be, they could be at any angle. But if it helps you to see the Z's and the F's and so on, turn your page around. What can I see? Well, straight away, if I know that that is 70, even if I don't know anything about parallel lines, I know that opposite angles, when two lines cross, are equal. So if that's 70, that's 70. And I'm going to write that in there. Even though I can put it in there, it helps me to put all this information on my, my diagram. Now, from parallel lines, I know that that angle there and that angle there are going to be the same as well, where you've got a line cutting two parallel lines correspond to the angles that are in the same position on each have the same value. So if that is 70, so is that. So B is 70. Now I can see I'm in a triangle. And in a triangle, the angles add up to 180. So that is 70 and 35 is 105. Take it away from 180, 180 take away 105. 75 degrees. So that one there is 75, which is angle C. D, the most common one to spot in a parallel line, is the sort of Z angle as they're called. That one is the same as that, so D is 35. Which means the only one I have left to get is E. And just like if that's 70, that's 70. If that's 35, that's 35. That's on a straight line. So E and 35 have to add up to 180. So that one is 180 less 35, which is 45 degrees. 1 mark for each. If you've got a diagram like that, put the angles in as soon as you recognize where they are. Don't just write your answers there, because by writing them there, you'll immediately see where else the same angles appear in the diagram. There are two regular polygons, X and Y. The size of each exterior angle in polygon X is 9 degrees. The interior angle of polygon Y is 120. So they're different bits. So for X, they're telling me the exterior angle. So one of the turns on your shape, that there is 9 degrees. And what you need to learn is that the number of sides is 360 degrees divided by the exterior angle. Or the exterior angle is 360 divided by the number of sides. So for this one, it's 360 divided by 9, which is 40. So it's a 40-sided polygon. 2 marks. For Y, we're given the interior angle. This rule works for the exterior angle, so you have to get, all right, 120, take it away from 180, 60 degrees is the exterior angle. So the number of sides is 360 not divided by 120, really common mistake, but that. Otherwise, they'd be asking you to do the same thing twice. Well, why would they do that? There's no point. So 360 divided by 60 is 6. So 6 sides. Question 18. Calculate the length x. So I have a right angle triangle. I know two sides and I want to find the third. Don't know anything about the angles, so it's not a trig question. It's a Pythag question. As soon as you recognize I'm working with Pythag, the first thing to do is to square your sides. So if you square your two sides, so you've got 14.6 squared, sorry, 213.16, 34.2 squared, 1169.64. So you know you've got to square your sides, job done. Then you have to decide whether you're going to add these two numbers together or subtract them. And all you need to do is just to think about it logically. If you were trying to find the longest side, then you need your numbers to get bigger, so you're going to add them together. If you're trying to find one of the shorter sides, you want your total to become smaller, so you're going to subtract them. In this case, I've got my longest side, so I want to add my squares together. So when I do that, I get 1382.8. Now, that's 14.6 centimeters high and 34.2 centimeters long. There's no way that the line that joins them together is going to be 1382.8 centimeters. So you've got to do one more thing to go backwards from working with squares to working with lengths, and that's the opposite of squaring, which is square rooting. So I've now got to square root my answer, and I get 37 point, and I'll work one decimal place again. 1 is in the one decimal place, the next one is bigger than 5, 2, and it's not area, we're staying with length, so it's 37.2 centimeters. That's Pythag. And then the final question on this test was to draw an accurate diagram. The diagram below shows a freehand sketch of a triangle ABC that is not drawn to scale. Use a ruler and a pair of compasses to draw an accurate diagram of the triangle. Well, let's do the 12 centimeters. So I'll got no idea how big this is going to be, so I'll work down the bottom of the page. 12 centimeters. A, B. Now, because you don't know any angles, this thing is of no use to us whatsoever. But the compass is a big friend, because what the compass will do is, first of all, if we measure a 9 centimeter radius, okay, so what I've done, compass point on 0 opened out to 9, and that's coming from A, and I'm just going to draw part of a curve. Everywhere on that curve is exactly 9 centimeters from A, so I know that C is on that curve somewhere. To decide where, I want to repeat that to draw a bit of a curve which is 7.5 from B. Back to my ruler, point on 0, change the compass to open at 7.5, compass point on B, there you go. Everywhere on that curve is exactly 7.5 centimeters from B. So where the 2 cross is where C must be, because that is going to be 9 centimeters from A and 7.5 centimeters from B. So there you go. 2 marks.